Okay, hello, grade 10th. I hope you guys are having a good morning. Yeah, so we're only starting the session now. I thought I would start a bit earlier, but that did not really happen or fly. So we're going to start it right now. And I just want to go back a little bit and actually do the corrections for the work that we had started last time in our session for the grade 10. So last time with the grade 10s, I did a bit of trigonometric equations because there was someone who had asked a question on trigonometric equations. And what I did is I left 8 problems for you guys to do so that you could see if like the concept that I had covered in the session last time was actually grasped. Okay, and the question or the game challenge said round off to 3 decimal places. So for theta, where theta is an acute angle. Okay, where theta is an acute angle. So the first question was sine theta is equal to 0.866. All right, and maybe what we can do is we can just answer these questions quickly, and then we can go and check out the 2 questions as well that were Euclidean geometry based questions. We can cover those and then we can continue from there. All right, we'll see what direction we can take from there. So yes, trigonometry was a term 1 topic, but as I basically was able to pick up from the one learner that said they needed assistance with it, this particular problems, I just decided let's just recap on it so that yeah, we can be good with that. So let's look at the first question. Sine theta is equal to 0.866, right? So of course with this one, okay, I don't know if there's anyone who actually was here for the session last time, and maybe they can just indicate in the comment section, you know, because I just want to check the people that were actually here for this particular grade 10 session and that actually had attended it, and then you obviously even did the questions, and they basically, yeah, were able to go through this. Okay, so we'll remember, guys, that when we say sine theta is equal to 0.866, I see in the comment section there, Tasha182, Tasha, hello. Remember what we said, we take when the trig ratio has been isolated on the left and there's a numerical value, that then gives us the opportunity to then take arc sine on the right hand side of the numerical value. Then we can utilize our beautiful calculator and say shift, then we press the inverse of sine in the calculator, the arc sine there, and then it's 0.866, as you see Lerato has typed in the comment section so beautifully for all of us to see. And then our answer, I think, as Tasha had indicated, is actually when we type in the calculator, we get theta is equal to 60 degrees. And if you look at this angle, this is definitely an acute angle, right? Oh, I thought when we round off to 3, yeah, we round off to 3 decimal places, right? Yeah, remember, let's just check. I just want to check the calculator here. Just wait before you throw stones at me. All right, I was just going by what my beautiful student in the comment section had indicated. So if we say shift and then we press sine 0.8 and then we say 66 and then we close the bracket, there it is, guys. All right, it's 59,997. so obviously we cut it off in the 3rd place there. All right, and then obviously the 0, what does it say to the 7? It says we stay the same. We stay the same. Okay, so if we're staying the same, then guys, then that means the answer is 59, 59.997. Okay, so it's not 59,996, Lerato, according to Mr. Calculator. Remember, 1, 2, 3, we cut off at the third. What does the 0 say to the 7? We stay the same. So therefore the answer is 59,997 degrees. Okay, because remember, there was a specific injunction from the question that we need to round off to what? To 3 decimal places. So to say it is 60 degrees means we did not we did not follow the instruction as per what we were told to round off to 3 decimal places. So always take into account, guys, the rounding off that has been specified, okay, so that we don't go wrong where that is concerned. Okay, the next question says cos theta is equal to 0.866. So once again, the trig ratio has been isolated. There's a numerical value on the right. So obviously we isolate theta. We take the, yes, very good, and Lerato. And then calculator, we'll just go to Mr. Calculator then. Mr. Calculator. So we say shift, we say cos, and then we say not comma, and we say 866, and we say equal. And then 3 decimal places, can you see there? 1, 2, 3. We cut off there at the 2. And then what does the 9, the fourth number, say to the third number? Go up, dear. And then it's like dear goes up. So the answer is 30, 003. Remember, this is an angle, so we say degrees, very importantly. Okay, I think so far so good. Threaded. Cos 3 theta is equal to 0.33. Okay, all right, so here cos 3 theta is equal to 0.33. Right, so the one thing we emphasized last time is that this here, this coefficient of the angle 3, we cannot just go ahead and say we're dividing both sides by 3. All right, because the thing is, whenever the coefficient of the angle is a certain numerical value that is not 1, then we need to first make sure, guys, okay, that's fine, you can go to the life science class, okay, yeah, obviously I'm going to post this, don't worry, okay, no problem, Lerato. Thank you for letting me know in the comment section. Okay, I love the level of professionalism that exists there. Okay, so yes, we can't divide by 3, so what we do is we have the trig ratio isolated. So we take the arc of cos on the right hand side, and then we allow the angle to be isolated with its coefficient, the unknown angle to be isolated with the coefficient 3. All right, please guys, let us not divide by 3 from the onset, because that is not allowed. All right, so we take the arc of cos 0.33, and we're going to go to our beautiful trusted calculator, of course. So let's just remove this that we have here. So then we say shift cos not comma 33, close the brackets, we get that one, 70,73. all right, and you know, I usually like actually doing the following, yeah, because obviously that answer we are going to divide by what? By 3. So that answer we go ahead and we just divide it by 3, yeah, so that we can get the answer immediately. So the answer there is 23,5. We have to round off to 3 decimal places, so the 577. Okay, Okay, yes. So we get an answer of 23,577. So there it is. Okay, what does this, what is it called? So look at the fourth decimal. What does the fourth say to the previous? 23,577. We stay the same, so it's 577 degrees. Okay, so just again, guys, just to repeat that process. Okay, remember what we said? We take arc cos on the right hand side, arc cos of 0,33. 3 theta is equal to that. No, we're not doing general solution, Madam Zelda. This is grade 10. Grade 10s don't do general solution. So this is grade 10. We're solving for theta. And obviously our theta, we have been told, is an acute angle. So this is different grade, madam. Okay, so we then divide by 3 both sides. All right. And then we get theta is equal to 23,577. So after taking arc cos of 0,33, then we can divide now by 3 to get the answer. So I just want to confirm again, because someone in the comment section said something that is making me think, all right, let's just double check. Then what do? We divide that by 3. We get 23,577. So indeed it is 23,577, because the fourth number, we know that it will say to the third number, which we're supposed to round off 2, it will say we stay the same. Okay, so yeah, that is the answer. Let's move on to the next question. 4 tan of 4 theta is equal to 4. Right, so if you look at this question, guys, 4 tan of 4 theta is equal to 4. Here, 4 has a coefficient. Okay, this is core maths, pure maths, grade 10. Revising some grade 10 term 1 work. So 4 tan of 4 theta. So 4 is the coefficient of the trigonometric ratio that we have here. And then 4 here is the coefficient of the angle. So obviously the trig ratio is not fully isolated because it has a coefficient. So our first step then is to divide both sides by 4. We are then left with tan 4 theta is equal to 1. So I'm sure you can see, guys, that dividing by 4 has no effect on the coefficient of the angle, but it has an effect on the coefficient of the trig ratio. And of course it should, because we know that division by this coefficient of the angle does not occur whilst the trig ratio is still there. Now we have tan 4 theta is equal to 1. The next step then is to take the arc of tan on the right hand side. Okay, so arc of tan 1. 4 theta is isolated, then we can say 4 theta is equal to arc of tan 1. Now we can divide both sides by 4 so that we can get theta. And this here, it's very easy. You can just put all of it in our calculator, and that's why I'm retaining it like this, because I just want to avoid having to write down the long value and then having to divide by 4 afterwards. So let's do this. Let's write it down. So shift of tan. So let's just do this here nicely. Let's do this. So we just say, then we can say shift tan of what? Of 1 divided by 4. Okay, one step. One good step. That gives us 11,25 when we press SD. Initially we got a fraction, but then when we press SD, it's 11,25. Since we're saying 3 decimal places, we just make sure we put a 0 there, okay, which is fine. 11,250 degrees. There it is. Okay. Okay. Hope we are good. So far, so good. Of course, if any questions are there, please in the comment section, use the comment section and ask your question if there is one. Okay, let's move on. No, it's fine, Lerad. Remember that that's 0. Okay, I think there is a sort of like a, what you might call if that 0 is not there, you know, like the examiner does take it as if that 0 is something that is there, even if you hadn't written it down. I don't think you would lose a mark still, but just to be safe, just put it there, you know, just to be safe. Otherwise, even if the 0 wasn't there, for 3 decimal places, if you write 11,25 degrees, you should still be able to get all of your marks, no problem. All right. So I hope that answers Mr. Flangerman there. But remember, 3 decimal places, you know, let's just do what we know, okay? Because we want to have 3 numbers after the comma if we are saying 3 decimal places, okay? All right, number 5. Sine of x minus 20 degrees is equal to 0.678. Okay, now we have a trig ratio. Then here in brackets, we have what we refer to as a compound angle. Okay, right? So very important, very important. Here, I'll post this, don't worry. No problem. You guys attend those other classes. You know that the recording here will be available for you to be able to watch. And by the way, to those who may have missed this particular lesson, this morning at 6:30, I uploaded the previous lesson that basically leads up to this game challenge. Okay, because I did trigonometry and Euclidean geometry simultaneously in the previous lesson. So the lesson is now uploaded. It's on the YouTube channel, the most recent video. You should see it. It's written grade 10 geometry term 2. Okay, it's got a yellow thumbnail. So you should check it out there on my YouTube channel. Those who are joining in for the first time, the YouTube channel is on my bio. Okay, if you go to my bio, the link is there. There's a WhatsApp channel link, and then there's a YouTube channel link. You can just go to my YouTube channel, it's there. So I've posted that, and then I'll post this obviously after I'm done. So sine of x minus 20 degrees is equal to 0.678. We know that the trig ratio is there. There's the angle there, it's compound. So once again, we take the arc of sine on the right hand side, and then x minus 20 degrees, okay, on the left is then now isolated. Then we evaluate this. The link of the YouTube channel, I said it's in my bio. Go to my bio information there. You know, in this TikTok channel, just go to my bio. The YouTube channel is also called Maths is a Game 5 to 7. Maths is a Game 5 to 7. But the link there is in my bio. It will send you directly to the channel itself. Okay. Now that minus 20, we can transpose it. It's plus 20 there. Okay. So when we take the arc of sine of 0.678, what we do is we transpose the negative 20. That becomes plus. So we just add 20 degrees to the arc of sine 0.678. And then that gives us an answer of 62, now look at the 3 decimal place. 62,687. That's 5, says what to the 7? We go up by 1. So it's 62,688 degrees if we are rounding off to 2 decimal places. I mean 3 decimal places, sorry. Okay. Yeah, so what I did here is I transposed the negative 20. Okay, after taking the arc of sine of 0.678, very important. Then we can transpose the negative 20, becomes plus 20, so we just add the plus 20 to this arc of sine 0.678, and we get 62,688 degrees. Okay, no problem. 5. Okay, we've got 3 more. Number 6, let's do number 6 up here. 3 cos x plus 30 degrees is equal to 2,121. Okay, coefficient of 3, trig ratio, compound angle 2,121. Okay, so once again, the 3 is a coefficient that must go. All right, we need to first take care of that. So we divide both sides by what? By 3. Then we left with cos of x plus 30 degrees is equal to, so we take our calculator, what's 2,121, 2,121 divided by 3, that gives us 0,707. There we have it. Okay, now we have back to that situation where there's a compound angle, there's a trig ratio, so obviously we need to take the arc of cos on the right hand side, 0,07, isolate the compound angle, bracket has been removed, so we take the arc of like what, of cos of that basic answer that we got here, that's 45. Okay. And then what do we do after that? We transpose, guys. We transpose the 30 degrees to the other side. Remember, ne? So x is equal to, when we transpose the 30 degrees, it becomes that 45 comma something something minus the 30 degrees when we transpose. So we just say minus 30 to this answer. And what do we get? 15, comma what? Comma 0, 0. What does the 8? The message that 8 receives from 6 is that we need to go up 8. We need to go up 8 by 1. Alright? Because remember, when the number is 5, 6, 7 or more, then basically it says to the previous number we go up by 1. So the answer is 15,009 degrees, because they said we need to round off to what? To 3 decimal places. Okay, I'm sure you guys have become experts now. It's like you're becoming expertise of trigonometric equation prowess. Right, moving on to the next question. 2 tan 2x minus 10 degrees is equal to 3,4641. Okay, once again, trig ratio, compound angle, coefficient, isolated value. So first things first. Yeah, Leradre. It's like clockwork now. You can see, can see it from a distance. So we grab our calculator, we check out what 3,4641 is. If we divide it by 2, 3,4641 divided by 2 is equal to, what is it equal to? Okay, that's what it's equal to here. 1 comma. Come on, Mr. Phone, stop being blurry. Why are you doing this to us? Why are you sabotaging us like this? Thank you. 1,73205. How important it is that when you guys write these things down, you don't write them out incorrectly, Sometimes when you look at your calculator, you may swap around the 2 and the 3, or maybe you'd swap around the 7 and the 2, things like that. Just always make sure that when you are writing down things, you write them down the way you see them. Okay, now you can take the inverse of 1,73205. 2x minus 10 degrees is now isolated. The bracket can be removed, which is fine. So we go there, we say the arc of tan of the answer that we had gotten, 59,9. Yes, until the last term. Yeah, so there it is. Yes, until the last number, 59,99. So 59,9999. There's 4 9s, there's 2 8s, there's 4 3. Right, then I know that what we are going to do is we are going to transpose the 10. That becomes plus 10. So all we are doing there is we are going to add the 10. That gives us 69,999. Okay, Then after that, we are going to divide both sides of that answer by 2. Do you see that? Divide both sides by 2, which is very important. So there we go. Let's divide by 2. Sure, you see. There's our answer, but we need to round it off to 2 decimal places. I mean to 3 decimal places. Now look at this. This is 9, 9, 9. The 9 here, what does it say to the previous 9? It says we must go up. When this goes up, it becomes like 1,000. And remember, this basically means that the 4 is going to go up by 1. So in other words, this becomes 35 degrees. Okay, and maybe someone else will be like, so don't we write 35,000 degrees? Okay, remember, like I said, guys, if you leave it like this, that's fine. Okay, thing is, when you get, if it's a whole number, all right, and obviously writing zeros is how you want to actually go ahead and get the answer. You'd rather, it's fine, you'll still be able to get all of your marks if you write 35 degrees, because if you round off to 3 decimal places, okay, yeah, remember those zeros are they are insignificant numbers when it comes to the actual value or the digit. Okay, okay. I see, Lerado, you play the safe game. Yeah, but I think your teacher then appreciates and sees that you're actually understanding that she or he had said round off to 3 decimal places, so you accommodate all the zeros. Eh? But there we have it. That's the answer. Okay. Yes. Thank you. These guys. Look at these guys. Comparing levels. Okay, let's look at the very last one. Two tan 2x minus 10 is equal to 3,4641. Guys, take note of what is there. This is 2 tan 2x minus 10. This is not an angle, this is just a value. Okay, so if I asked you the question, how many terms are on the left hand side, then I hope you guys know that on the left, if I asked how many terms there are how many terms on the left? There are, hopefully you all are saying the same thing, there are 2 terms on the left. Okay, if you look at this previous question that we had there, if I asked how many terms there are here, hopefully you are all telling me that there is not 2 terms here, there is only 1 term. And 2x minus 10 is in brackets, which means this is part of the angle. We refer to this, you'll only learn this a little bit more in grade 12 as well. We refer to this as a compound angle. Okay, yeah, so this question is very different from this one. Okay, so here, 2 terms. What we do here, we are going to transpose the constant term, which is tan. This is not an angle, this is just a numerical value. Okay, it's a separate term from tan 2x. Because why are we transposing the tan? We are working towards isolating tan. Now we are left with 2 tan 2x on the left. If we add the plus 10 there, I'm sure you guys know that if you add the plus 10 there, 3,4 will give you 13, right? 4641. Okay. Okay. Now we need to do what? Divide both sides by 2, the coefficient of the trig ratio. Okay. Okay, so we go there to our calculator, we write down 13,4641 divided by 2. We get that answer. Then we take the arc of tan. The arc of tan. Okay, then we go there to our calculator. We know that shift arc of tan, what the answer was there previously, 81,55. Okay, then we can straight up, we know that what we are going to do with the 81,55 is that we are going to divide it by 2. So we can say x is equal to, let's divide that by 2. That should give us an answer of 40,775. 40,775. And we say 775 because the 4, which is the fourth number, says what to the 5? Stay the same. Let's not forget this is an angle, so we write degrees. Okay. So to all my trigonometric equation people that were like, hey, Trig says a pain, the equations are not popping. I hope at least now we have a glimmer of light. There's light and there's more light, and there's a lot of light that we can now see. Okay. Hopefully there's light now in our lives. Okay. Okay, any questions? Okay. All right, that's very important. Okay. Now, where trig is concerned, guys, for the grade 10s that are here, the equation, okay, here's the equation. This was the equation. 2 tan 2x minus 10 is equal to 3,4641. That was the equation. Okay, awesome. All right, then this was the previous one that we did, because unlike this one, it was 2 tan 2x minus 10, the compound angle in this case, equal to 3,4641. That's how we had done that one. Our rounding off was round off to 3 decimal places. This was the first one we had done, the second one we had done, the third one we had done, the fourth one that we had done, the fifth one that we did, and then last but not least, don't move fast, okay? Okay, first 1, 2, 3, 4, 5. Second 1, 2, 3, 4, 5. Third 1, 2, 3, 4, 5. Thank you so much, user. That's a very generous comment. Nkayowa. Danko. Fourth 1, 2, 3, 4, 5. Fifth one 1, 2, 3, 4, 5. Pure. Sixth one 1, 2, 3, 4, 5. Then of course, as I said, that was the sixth one, the one I showed you. Sixth and the seventh, sorry, this was the seventh one, sorry, I'm saying this is the sixth one, but it's the seventh one. But I already showed you the beginning, and then this was the last one. Okay, so those are the corrections for our game challenges that I had given you the last time. Hopefully now we are so clear and we are all ready to go jump on the bandwagon of what we did after that. Then remember that we then last time changed the channel to Euclidean Geometry. All right, we changed the channel last time to Euclidean Geometry, okay, and we looked at some of the concepts that we had revised in previous grades, that we had established in previous grades. You know, the fact that angles on a straight line, if a ray is drawn from a point on a line, then the sum of the adjacent angles is 180 degrees. Okay, so if we have we have a nice line there are two angles next to each other, then we said that the sum of those two angles is 180 degrees. So that's why we say angle B1 is plus angle B2 gives us 180 degrees, and you said that our acceptable reason that we use utilizing that document, the acceptable reason document, angles on a straight line. Okay, and for short, angles on a STR dot line, because in grade 10 we need to familiarize ourselves with the acceptable reason document so that we can make sure that we use the accepted universal reasons so that we don't lose out on the marks that are due to us. Number 2, we also learned that if the sum of two adjacent angles, and the word adjacent means angles next to each other, like this angle and this angle are next to each other, guys. These are adjacent angles, next door neighbor angles, if you want to call them that, adjacent, next to. So if the sum of two adjacent angles is 180 degrees, then we say the outer legs or arms form a straight line. Okay, the outer legs or arms form a straight line. Okay, yeah. So let me just let me see if I don't have this thing, right? Yeah, I'm sure some of you are like, why is this guy talking about the acceptable in grade? You guys are coming from grade, you're coming from grade 9, right? In grade 9, so look at this document with me, guys. This here is an important document. I want you guys to familiarize yourself with this document, because you see, people that are markers in the exam centers in grade 12, we know that this document, it informs the reasoning that all learners should use when they are doing Euclidean geometry, grade 10, 11, and 12. In grade 12, obviously, there's no doubt there's this common way in which reasons ought to be written. If you look at the top there of this document, it says, in order to have some kind of uniformity, the use of the following shortened versions of the theorem, we are encouraged that we should use them. Okay, so if you look at the first statement there on the left for theorem statement, hopefully you guys are all looking at this with me. It says the adjacent angles on a straight line are supplementary. Do you see that? The adjacent angles. So I told you guys that adjacent angles are angles that are next to each other. So these angles must be next to each other in order for them to qualify as being supplementary. Okay, and if you look at that acceptable reason column there, it says angles, and you can see that the symbol angles on a straight line. Okay, so please guys, let us get onto the bandwagon of this acceptable reason document. If we can familiarize ourselves with this, then we should be fine in grade 10, 11, and 12. Okay, so please, grade 10s, make sure that we stick to this. When I teach my grade 8s and 9s even, I expose them to this document because I want them to be familiar with this sort of reasoning from the beginning of grade 8. So when we do grade 8, because you start with this, okay, in grade 8, the lines and angles are established in grade 8, then they are developed in grade 9, and then in grade 10, you guys need to become people that know how to use the document. So let me do this. I think someone is saying, let me turn off. Let me do that actually. Let me turn off the comments for now. So please, guys, important document this one. All right, I'll share this. I will share it on the page. I'll share it in the group. I'll share it as a video as well. You know, this is something that needs to be, you need to print it out. You need to, you know, when you start Euclidean geometry at your school, you know, they should provide this document for you so that you can have it available. It should be on your wall. This is one of the documents that should be on your wall so that you know the right reasons to be using. So adjacent angles on a straight line are supplementary. If you look at the second statement, it says if the adjacent angles are supplementary, the outer arms of these angles form a straight line. Okay. Now we use this one to prove that a line is actually a straight line. Okay, not all lines are straight, guys. You know, in order for us to prove that a line is straight and that the outer arms actually form a straight line, it is important to prove that the angles that are next to each other are actually supplementary. If the angles next to each other are supplementary, then it means that the outer arms form a straight line. Okay, so when sometimes in questions they will say prove that this is a straight, prove that AB is a straight line. All right, and then that reason there is used whenever you have been able to prove adjacent angles supplementary. We use that one when we want to prove that a certain line is actually a straight line. Okay, adjacent angles supplementary. Okay, adjacent angles supplementary. Right, so adjacent angles sub for short. Look at the next one. The adjacent angles in a revolution add up to 360 degrees. Okay, we say that those are angles around a point. Angles around a point add up to 360 degrees. I'm sure you've seen this in grade 8, you've seen it in grade 9, angles around a point. If you look at the acceptable reason, you can either use angles around a point, angles around a PT, or you can say angles in a rev. Yeah. Change the card a little bit there to the next statement. Vertically opposite angles are equal. You can see there. Vertically opposite angles are equal. There is our acceptable reason. Vert op angles equal. Then after that you have the three statements that speak to lines that are parallel. I'm sure you guys remember that where lines are parallel, we have that F-U-N, fun, right? The F shape, the U shape, and the N or the Z shape. So the first statement, if AB is parallel to CD, in other words, if lines are parallel, then the alternate angles are equal. In other words, the Z shape there, we are talking about the Z or the N shape, okay? And look at the reason. You must write alt angles and you must state the lines that are parallel. If you look at the acceptable reason that you should have there, okay? And the next statement, if AB is parallel to CD, then the corresponding angles are equal. Corresponding speaks to the F shape. Top, top, bottom, bottom. Top angle, equal. Bottom angle, equal for your F shape. Okay. Then you look at the next statement, co-interior angles. That speaks to your U shape. Your armpit angles. You know your armpits, the ones that sting, you know, your armpits, those are the angles, your angles at your armpits. Yeah, your armpit angles. So that speaks to that, the U shape, all right? The U shape. Okay, let me do this. Sorry guys, let me do this. I think I didn't want to accept people like this. Yeah, sorry. It was not supposed to hide that. Isn't Larato supposed to be in a class?
I think they postponed the class.
Oh, they postponed the class. Okay. Okay. So Lerato and Margaret, hello, 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 hello to all of you all. I think it's good to have people in discussion with this one because I don't want to just be rambling here. So yeah, do, do, do we know this document? You've seen it before?
They didn't give us, but I think they gave us notes.
No, okay. But now what I do want you guys to know is I want you to be familiar with this document. This is a very important document. Very important. Okay, so it's good that it's okay that you've been given the notes, but what I want you guys to do is to actually be familiar with this because, like I said, this is like the department in their official documents for Euclidean geometry. This is a document that they encourage us as teachers to share with you. Okay, and you can see that it even says that the statements, the versions of the theorem statements is encouraged. Okay, there at the top. Yeah. So far, do you see all of these acceptable reasons on the right column? Yeah, that is the short form that they would like you guys to have whenever you write your reasons. Yes, see. So if you guys can use that, then you should be good. Not that guy, I see you there as well. Hope you're good.
I'm good, sir.
Yeah. And you, what about, are you familiar? Are you familiar with this document?
Yes, sir. I'm familiar with it.
Okay, that's good. That's good. That's good. When did you first get exposed to it?
Grade 8.
Grade 8. Nice. So that means your educator as well saw the importance of you guys getting exposed to this earlier on.
Yes, sir.
Yeah, no, that's good. That's beautiful. Right. So guys, the first 1, 2, 3, 4, 5, 6, 7 statements, right? Up until where we say if AB is parallel to CD, then the co-interior angles are supplementary, right? Those 7 statements, hopefully we are all clear about them, those statements and their reasons. All right. You can see for the alternate angles, they use alt angles, and then you state the lines that are parallel. Now remember, it's not always going to be AB parallel to CD. Sometimes you'll see different lines, and maybe it's ZM and PT. Maybe it's NM and LF, okay? You always consider the lines that are in the given diagram, and then you please write those parallel lines. Not always AB is parallel to CD, even if AB and CD are not there. Yeah. Okay. All right. And then I don't know if there's any questions from you guys, Lerado and not that guy, from the 7 statements that I've gone through so far. If there is, I would like to entertain those. If there isn't, then we can continue.
No question for me.
All right. Lerado says no question. Hello, Tasha. I think we have someone else in there. Okay. All right. If there's no questions from any of you, then we can continue. Any questions? Any at all? Yeah, I see there's a low one there in the background. Okay. I think let's mute that mic there. All right, then if we look at the 3 statements, then after last 3 statements lines.
One count.
Okay, the last 3 statements, guys, for the lines, we are told if the alternate angles between 2 lines are equal, right? Remember, guys, alternate angles are angles that are formed in that Z shape, all right? All right, so the position is what we are talking about. If you are saying alternate angles exist whether lines are parallel or not. They are only equal, those alternate angles, if the lines are actually parallel. So alternate angles are angles that are found in that Z-shape position. That's what we say when we are saying alternate angles. So it says if the alternate angles between 2 lines are equal, then what can we conclude about the lines? It means that the lines are actually parallel. Okay. The second last statement says if the corresponding angles, now if we're talking about corresponding angles, we are talking about the angles that are found in the F-shaped position. Okay. If the corresponding angles between two lines are equal, then the lines are actually parallel. And then lastly, if the co-interior angles between the two lines are supplementary, what are co-interior angles? Those are angles that are found in the U-shaped position, the armpit angles. If those two angles are equal, then we say that if the two angles, are supplementary, not equal. If the two angles are supplementary, then the lines are actually parallel. So the last three statements, guys, we use them, or the last three reasons, we use them whenever we are asked the question. They can be used whenever we are asked the question, prove that two lines are parallel. In order to prove that two lines are parallel, you can either check for the Z-shape situation. Do I have two alternate angles between two lines that are parallel? Do I have maybe two angles that are corresponding and are equal? Do I have two angles that are supplementary? Because if they are between those lines, then it means that the lines are parallel. And my reason can either be alt angles equal, if there are two angles that are alternate that are equal, corresponding angles equal, if there are two angles that are corresponding that are equal, co-interior angles supplementary, if there are two angles that are supplementary between the two lines. Okay, but it must be those angles in those respective positions in order to use each reason. If you're going to use alt angles equal, it must be those alternate angles are truly equal. If you are going to use co-interior angles as supplementary to prove that lines are parallel, then it must be that those angles that are in the U-shaped position are supplementary. Okay, so these are very important. So I'm going to switch this off a little bit because this document is very important, like I said, and what I'm going to do is, like I said, I'm going to share this document for those that may probably not have gotten exposure to it. Okay, if you look underneath the lines, there's triangles. All of the theorems that relate to triangles are listed there. Okay, you see sometimes we use this for triangles. The interior angles of a triangle are supplementary. All the three angles of a triangle they add up to 180. Okay, there are the reasons that you can use. One of three. There's angle sum in triangle, the sum of angles in triangle, or you can use interior angles of a triangle. Okay, one of these three are acceptable. You can use them whenever you are dealing with a situation when you can see that three angles in a triangle, they add up to 180 degrees. Then the second statement, the exterior angle of a triangle, there under triangles, the exterior angle of a triangle is equal to the sum of the interior opposite angles. I think we also saw that one once. We also saw the diagram, that the diagram needs to be, let me just for a second there, just for a moment there, I want to do the following, because these things are very important, and when we know these things and they are clear for us, then it's fine. We are good to go. All right. Just as we are dealing with triangles here. Okay, if you remember from when we did the live session last time. Okay, okay, so this is obviously where it relates to the triangle. The three angles of a triangle, they add up to 180 degrees, and then there's those three reasons that we actually looked at in the acceptable reason document. The exterior angle, we must know that the exterior angle we are talking about needs to be in line with the side of a triangle. All right, so the exterior angle is equal to the sum of the two interior opposite angles. So in other words, angle A plus angle B will give me angle C1, but it can never be this. I hope we remember that. It can never be that, okay? Because this angle C1 is not in line with the side of the triangle. The angle must be in line with the side of the triangle in order for it to qualify as that exterior angle that is equal to the sum of the two interior opposite angles. Okay, so that's just something that I love emphasizing, because it's amazing how many times learners can actually conclude that They look at this diagram, they're like, angle C1 is equal to angle A plus angle B, and you're like, Haibo, but this angle, it's not formed as an exterior in line with the side of the triangle. So we can't therefore say that C1 is equal to angle A plus angle B in this situation. It's completely out. Then, let's not forget Mr. Isosceles triangle, of course. Mr. Isosceles triangle, we know that if two sides are equal, then we can say the angles, angle B and angle C, are equal, and this is the acceptable reason. In the document, it's there. Angles opposite equal sides. All right? Very important. Alternatively, if we are given that the angles are equal, we can conclude about the sides. AB is equal to AC. And the reason is sides opposite equal angles. It's there in the acceptable reason document as well. All right. So the theory that relates to triangles is also there. Right. So then the last time we were together, guys, we looked at some questions. We really just looked at some questions briefly, which are just a revision of the grade 8 and 9 content that we did. Okay, we found the value of x. Of course, we found the value of x for this particular diagram. We found the value of x here for this particular diagram, noticing the relationship that exists between these two angles. We found the value of x here as well, okay, noticing the relationship that exists with this angle and these two angles, right? The fact that this is the exterior, these are the two interior opposite angles, so therefore we can say x plus x is equal to 150 degrees, and we use the acceptable reason as per the document that we have just looked at. Then we can solve and get the value of x. All right. We looked at this situation as well, and then I gave you two problems to do. And right now, I wish to actually get someone here to lead me along and help us to be able to answer these questions so that we can now go ahead and do, more. We need to revise a little bit this grade 8 and 9 sort of like geometry, because the grade 10 geometry, guys, is just literally the foundation of the grade 10 geometry is our grade 8 and 9. But I fear that maybe some of us, we are still a bit shaky with the grade 8 and 9 geometry, and therefore it will affect how we do in the grade 10 geometry. Okay. So is someone ready to help me with this? Determine x giving reasons.
So when I texted you, you added the G and the H and F.
Okay, where did I add the G? What was here?
You wrote E.
E here, and then here?
That's G.
And then here?
There you didn't write anything.
Okay,
I thought,
here.
yes.
Oh, okay. All right.
Then the F is opposite to G.
Where? Here?
Opposite, like the next door.
Did I write F here?
Yes.
Okay, then I think I shouldn't have. I think there was definitely an error in my side because I wanted to label the points of intersection. Okay, so sorry, my mistake there. Okay, so yes, I did to add these letters so that we can be able to have a little bit more information for that diagram. Okay, so yeah, 2x minus 60 degrees is the angle on the top of this parallel line, but it's on the right side of the transversal line. And then x plus 30 degrees is the angle at the bottom. It's on the bottom, but on the right side still of the transversal line. This is top, this is bottom. So these two angles, if anyone thought maybe corresponding, no, these two angles are definitely not corresponding angles at all. So the question is, how do we find the value of x? How do we solve for x in this particular question? Any idea?
I said G is equals to 2x minus 60 vertical opposite angles.
So you said this is equal to 2x minus 60 degrees. Okay, now just bear with me here. You said G, Remember, G indicates this particular point, okay? Now,
Okay.
G, if you are saying to me G, remember, you are not being specific to me as to what angle you are referring to. Yeah, so you need to specify the angle if you are basically taking that direction. I'm just gonna write down what you are saying, but obviously there are certain things that I want us to take particular attention to whenever we specify an angle. So we can't say G is equal to 2x minus 60 degrees, but we can specify, because I'm sure you are referring to this angle, aren't you?
Yes.
Yes, all right. But G is this point, okay? And I need you to tell me this angle. What is this angle by convention?
AGF.
Thank you. AGF. You can definitely say AGF. Or you could say, if you want to,
FGA.
exactly,
Yeah,
you can say FGA, right? The middle letter denotes the angle. So you can say AGF is equal to 2x minus 60 degrees. Okay. Then your reason is what?
Vertical opposite angles.
A vert op angles equal. All right. Okay.
Then I said, can we see the diagram?
Sure. So I update my diagram 2x minus 60 degrees.
Then let's see. I said C let's see, man. What is it? D no, whoa, say whoa. CFH is equals to DFH, which is x plus 30.
So you're saying C F
H
H is
is
equal to?
equals to D. No man. Hey, something is wrong, man. Ish, what's that thing, man? What I'm looking for?
I actually liked what you were saying. You were saying CFH is equal to? What is CFH equal to?
DFH.
It's equal to
DFH.
B
DFH.
DFH. So you're saying CFH is equal to DFH.
Yes, and that all equals to x plus 30.
Okay, just hang on there. You are saying CFH, meaning this angle, is equal to DFH. Is that true?
No.
No.
Okay.
I want to say the opposite angle. No, the problem is that the letters.
Which letters?
Like I want to say x plus 30 is equals to F, and vertical opposite angles.
Oh,
I think we can say CFG or GFC.
Oh yeah, I see it, Tasha.
Okay, Tasha, you were saying? Let's just hang on there. You were saying, Tasha, what are you saying?
I'm saying x plus 30 degrees is equal to angle CFG.
CFG.
G, yes.
Yeah.
Okay, so in other words, you're saying CFG, this angle, CFG,
G is equals to
is equal to x plus 30 degrees. Okay, I agree with you. What's the reason?
a vertical opposite angle.
Okay, vert op angles. Okay, so I'm gonna update my diagram x plus 30 degrees. Okay,
Then we say AG plus CF is equals to 180 co-interior angle.
okay,
AB is parallel to CD.
okay, just one more time. You are saying, just repeat from the beginning.
AG.
Okay, you are saying AG, as in like AG, just like this.
Yeah, it's like an angle. Oh, I can say it's an angle. Like I want this part of the angle. Or G. Guy.
AG. What is AG?
I want to say this the G.
So you want to say the G? Then say it. Say it. How do we name? What is the conventional way to say this angle?
Yeah.
Using the letters that we have. Come on, you can do it. You've told me,
A
for instance, you've told me that this is AGF. I agree. 2x minus 60 degrees. I agree. You told me that CFG is x plus 30 degrees, which is I agree with you. Now
Well,
tell
that
me.
means I'll say AGF
Okay,
plus
AGF
plus I mean
plus
CFG is equals to
CFG.
FG is equals to 180.
CFG. And what are these? What are these? They are
Go
angles, right?
into angles
Okay.
then
Is equal to what?
180 degrees.
180 degrees. What's the reason?
Co-interior angles.
So co-int angles. Give me the line right after
AB is parallel to CD.
Thank you. AB is parallel to CD. Okay, nice. So AGF, what's AGF? 2x minus 60 degrees, because you got it for me previously. And what's CFG? X plus 30 degrees.
Then from there we solve.
Yeah, there we go. Then we solve. Okay, you tell me. 2x.
3 plus x. 2x plus x now, equals to 180. Yeah, let's say that plus
Okay,
8 equals to 180. Then 3x
3x
is minus 30.
minus 30
Since
degrees.
it's 30 equals to 180.
Okay,
3x is equals to 180 plus 180 plus 30
180 plus 30. Very good.
is equals to 210. Then divide by 3.
We divide by 3.
Then you get 70 degrees.
X is equal to 70 degrees. Awesome. Okay, that was all.
Tasha, thank you.
Yeah. Okay, nice. Okay, that was well done. Nice team effort. All right. And guys, please, man, this conventional way of specifying the angle using 3 letters, the middle letter giving us the actual angle. Let us become familiar with this, okay? Because examiners won't won't be merciful to you when you don't specify the angle that you are talking about, right? So you need to be specific about the angle you are referring to. That makes it easier for convention, okay? The funny thing is, like for instance, I loved the way that you guys worked together in that situation to be able to get to the actual answer at the end. Okay, that's one way you could have done that question. That does not mean it's the only way. It always depends on what your eye can see when you are actually doing the problem. Someone else may have done it differently, but still arrived at the same answer. So that's what's beautiful about Euclidean geometry. There's not one way to get to the answer. There are multiple ways to get to the answer. All right. Okay, let's move on to the next one. Let's see. Here, we are asked to find the value of A, the value of the value of C. Okay, not that guy. You want to say something?
Sir,
Yeah.
at the previous equation,
Sure.
can I ask something?
Yeah, go ahead.
Down there at the equations, go to the equations. Instead of saying AGF plus CGF, could you just say G plus C? I mean G plus F.
No.
Angle G plus F.
Remember, if you say angle G, all right, angle G is broad. It's not specific. Okay. If you are talking about angle G, maybe someone else will be saying it's because G itself is this entire. It's this point, and it refers to actually the angle, the entire angle. All right.
Okay.
So you have to specify that. This is what I'm getting to here, is that you need to specify the angle. That's why usually before you even get into Euclidean geometry deep in grade 8 and 9, in grade 8 and 9, they first go through with you how to name the angle, how to identify the angle. All right. So that's why I'm saying you guys need to be specific. So if you are talking about G from this side, there are two ways in which you can refer to this G this side. It is FGA, or you can say angle AGF. All right. So it can either be angle FGA or angle AGF. So it's very important. The middle letter will denote the angle. If you are talking about this angle, this side, angle F, then you can either say this is angle CFG or angle GFC. All right. So we need to be specific, very specific. Otherwise, if you're not specific, right, I cannot know what you're talking about, you know.
Okay, sir.
Yeah, you need to treat me like, even though you know, it's like, teacher knows. But the thing is, you need to treat me as if I know nothing. So when you write down, I need to be able to follow along. So for instance, if I look at this, okay, the way you guys answered, the first thing you said angle AGF is equal to 2x minus 60 degrees. That's what you said, right? All right. Now, when I go to the diagram, I look, they said AGF. Oh, this angle. You see, so I know what you are talking about. Okay. And you said it's 2x minus 60 degrees. And you said the reason vertically opposite angles. Makes sense because this is 2x minus 60 degrees. So this should also be 2x minus 60 degrees. And you specified the angle. Okay. Then we update our diagram with the new information. It's correct, Moss. 2x minus 60. We move on to the next thing. CFG. Where is CFG? CFG. Oh, they're talking about this. What did they say? It's x plus 30 degrees. What's the reason? Vert op angles. Oh, it makes sense. This angle and this angle are equal. So it makes sense, you know? Okay. Then after that, I update my diagram with the new information. Then we move on. Now you are saying to me, AGF, this angle, plus CFG, this angle, is equal to 180 degrees. What's the reason? Co-interior angles. Oh, this is the U shape. These are angles that are in between two lines that are parallel. And it's the U shape because fan, if you remember, co-interior, fan, the armpit angles, okay, they add up to 180. And look at my reason. Co-int angles, I state my lines that are parallel. There they are. AB is truly parallel to CD. Then from there, algebra, I just solve for x. And guys, please now, at this stage in grade 10, all of us should be affluent in solving for an unknown variable. Okay. All right. So I hope that's clear. Right. So now, not that I hope you are good. So please, let's get into the habit. All right. That's one of the things that we need to make sure we pay attention to detail, specify the angle by convention. Okay. Yeah.
So on the second diagram, I think there is a missing letter because the lines are parallel.
Yes, the lines are parallel. That's very true.
So where's the other letter that states your ZQ is parallel?
Okay, let's put let's say x. Let's put x here. Okay, thank you for that. All right. Okay. Yeah, it was night that day when I was doing this. So almost night stuff. Okay, let's put P as well here, just so that we have a complete letter diagram. All right. Okay.
I said, Mina, on this diagram, I said is the angle Z.
The what? Sorry?
Angle Z. Do you see angle Z?
Yes, angle Z. I see that.
Is equals to C equals to 55 degrees.
Okay. So C, in other words, is equal to 55 degrees. That's what you are saying.
Corresponding angles, ZQ is parallel to YZ. YX, man, sorry.
ZQ parallel to YX. Okay, C is equal to 55 degrees, right? Now, if you look at what she said, corresponding angles. What are corresponding angles? The F shape.
The shape.
On top of this parallel line, there's an angle. On top of this parallel line, there's an angle. So indeed, this is 55 degrees. I agree. I can update my diagram and say 55 degrees belongs there at C. So 100% correct. I agree with you wholeheartedly. 1 mark for the statement, 1 mark for your reason with your parallel lines, 100%. And you see, we use the acceptable reason, corresp angles, and then we state the lines that are parallel. ZQ is parallel to YX, or YX is parallel to ZQ. Okay. Yes, then
Then you say B plus 55
you say
equals to 180.
B plus?
Angle B plus 55 equals to 180.
Okay, what would you say is the reason for that?
Co-interior angles.
Okay, so hold your horses. You are saying B. Remember where B is. This is B. And then 55. Which 55? Are you talking about this 55?
Yes.
Okay, and you are saying these two angles are?
Oh, never mind, sir, never mind. I see, never mind.
Okay, so very important, right? Because if you are saying B plus 55, now it's very easy to think maybe that these two are co-interior. But remember, co-interior angles, it means this entire angle, A plus B together, must then, with this angle, add up to 55. So if we knew the entire angle, we would say that. All right. We can't say B, which is just a portion of this angle, plus this one is 180. All right. Okay.
Sir, can I answer?
Yes.
In
Sure.
triangle YZQ.
Okay. I'm gonna write this, but like I said, if it's not on, then I'm going to actually obviously identify what is not on. So you said in triangle what?
YZQ.
YZQ. Yes. What about that triangle?
Angle Z
Okay. This angle
is equals to angle Q.
Okay, angle Z is equal to angle
Q,
which is
equals
equal
to 55 degrees.
Okay, what's
The reason is angle opposite equals to sides.
Angles opposite equal sides. Remember most of what we said last time. I don't know if it was actually you. You seem to always be available in the in these sections where we have interactive lessons. So in this situation, sides is plural. Okay, remember, sides reverses a side. So if you say sides, you don't have to worry about saying two sides because more sides means plural. It's more than one. So if you say angles opposite equal sides, in the acceptable reason document, it is angles opposite equal sides. So you are safe when you write angles opposite equal sides. Are we happy?
Sir, what
Yes.
if I use the reason of saying like YZQ is an isosceles triangle, which means that the base angles will be equal?
All right. Now, Tasha, that is 100% correct. And I think in grade 8 and 9, that was acceptable, right? But
Yes.
you see now in grade 10, 11, and 12, for those learners that are doing CAPS, we need to subscribe to this. You are 100% correct in saying this is an isosceles triangle, no doubt. And when you are saying the base angles of an isosceles triangle are equal, you are also correct. But you see, the thing is, there's a convention that we are using in grade 10, 11, and 12. And we need to subscribe to angles opposite equal side. The base angles of an isosceles triangle is not really embraced in grade 10, 11, and 12 by the examiners. Not even. So don't even go there anymore. Let's stick to angles opposite equal sides.
Noted.
Thank you, Tasha. Thank you. I appreciate your humility. All right. So that is something that, I mean, I remember. I think I was probably a first a first-time teacher, probably in my second year as a teacher. And I remember we had a workshop on that, and there was a particular educator that was more seasoned and experienced than I was at the time, because I was like, I was still new in the field. And they brought that up, like this idea of base angles of an isosceles triangle. At the time, I was like, yeah, base angles for isosceles triangle for sure for grade 10s. But then that person said, no, guys, we are in grade 10, 11, and 12. We must ensure that our learners, they utilize this as the reason. So if they see an isosceles triangle and they can see that the angles are equal, please, guys, the angles here are opposite two sides that are equal. So we must then encourage our learners to write angles opposite equal sides. Are you with me? So I'm glad you noticed that one, Natasha. Okay. So can we
Then
go on?
I said angle Y
Okay.
is equal plus 1 plus angle Z plus angle Q
Yes.
is equals to 180 degrees angles in a triangle.
Okay, now remember the three conventional ways in which we actually, from our acceptable reason document. So now I'm encouraging you guys to do this acceptable reason document approach. Let me just for the benefit of everyone, I'm just gonna go there again. I don't want to go there. There we are. Under triangles, the interior angles of a triangle are supplementary. There we have three viable options. You can use angle sum in a triangle. Okay, I hope we all can see where I'm at. Or you can use sum of angles in triangle, or you can use interior angles triangle. All right. So when you must subscribe, like, share, and subscribe.
The sum of angles in a triangle. Okay, so
Yeah, all right. So that's why I'm going to really like this. This is like literally going to be our Bible, if you want to put it that way. I'm going to actually literally not accept a reason if it falls outside the scope of these reasons. Okay? We need to subscribe to the acceptable reasons, and the sooner we can all do that, then the easier it's going to be for all of us. And I know sometimes, guys, it's very hard to change something that we've been doing for years, you know. But now we need to subscribe, and when we do that, it's going to make life very sweet and easy for us, and good, because we'll be doing the right thing. So which one did you want me to write here? Because I'm going to write what you.
sum of angles in a triangle.
Okay. All right, there it is. Acceptable reason there. Okay.
A
A
plus 55 degrees plus 55 degrees is equals to 180 degrees.
Okay, nice.
Then A is 55 plus 55 is 110.
110.
180. Then A is equals to 180 minus 110.
Okay.
And A is equals to 70.
Nice. Updated diagram. Yes. A is
Then we
equal
go
70.
to number B. Then we say A plus B plus C is equals to 180 degrees angles on a straight line.
A plus B plus C is equal to 180 degrees
Angles on a straight line.
on a STR line. So here's the thing. A plus B plus C. If you see all three of these angles, they start from one side of the straight line and they complete. So because they start from one side, complete the other side, we can say these three angles, they are actually adding up to 180. Okay, Okay, they are not just next to each other, but they are next to each other. They complete a straight line from one side of the straight line to the other, next to each other. So then we can say that these three angles, they add up to 180, as you've said. So the values of A
is 70 degrees
70 degrees
plus B
plus B
plus 55 degrees
plus 55 degrees
is equals to 180.
equal to 180. Awesome.
B plus 70 plus 55 is 125.
Okay, 125 degrees, yes.
180. B is equals to 180 minus 125.
B is equal to 180 minus 125.
B is equals to 55 degrees.
B is equal to 55 degrees. Okay. I am very pleased. Very, very pleased. Thank you. Thank you, Lerad. Nice. All right. Very well done. Okay. So, like I said, and I'm saying again, you could have, if you wanted to, used different approach altogether and still got into the answer. So for instance, I saw when Lerato said, when Lerato got the angle Q, the minute Lerato got angle Q, you know, for me, I saw that and I was like, oh my soul, Lerato got Q. That means I can now tell you what B is because I saw alternate angles. You see?
Yes.
Yeah, I saw alternate angles for B immediately myself. All right. And I was like, B is equal to 55. Right. So it all depends on what you see. But what you see must be in the theorems of geometry that we have established in the grades that we have done. It can't be something that is, you know, removed from the theorems that we have learned. And you must make sure that you are sure about what you learned in the theorems. Because if we say the wrong thing, then we are going to write the wrong answers. Here's another thing that I want to just emphasize as well. Because Lerato said in triangle YZQ, you see this here is very key. Lerato said in triangle YZQ. Because Lerato said that, it immediately turns my attention into this triangle. All right, as someone who is marking Lerato. Then Lerato, you can see what he said, what she then said. She said angle Z plus angle Q plus angle, so it was angle Y, sorry, plus angle Z. So angle Y. Now remember, Y here represents so many other things here, all right? Because Y is a point, but it represents, you could say it represents this entire angle. But because Lerato said in triangle YZQ, she could then say angle Y because she turned my attention to the triangle that she's speaking about. And as a result, she did not have to say to me ZYQ. She could say angle Y because she told me the triangle she is referring to. So that's the only way you can actually just write a single letter as an angle. You know, it's when you specify the triangle. If you don't specify the triangle, then you have to say this is ZYQ, if it makes any sense. So it's very important for that. Okay? I just wanted to emphasize that point. Otherwise, I'm happy, I'm pleased. I'm very pleased. Okay. I don't know if there's anything else, but I think what we can then do is we can look at other problems. Or we can look at other problems that people can actually, you know, check out and do. Okay, unless there's a specific question that someone has, or a specific comment, or maybe something that you want clarity about. If not, I want to actually give more and more problems so that we can iron out the basics that we have established already. So here we are. I'm gonna give you a few. I'm going to allow you guys, those who are on the live, to actually do some work, right? I'm going to give you some work to do. Let's do this, okay? So this is CAD. So for each question is find the value of x giving reasons. Okay, because I want us now to really start using the reasons, the acceptable reasons that we have learned. Okay, this is an opportunity for us to really iron this out. So I'm going to give you a few problems so that we can really get that going. So I'm going to give you some time, and then after some time has elapsed, I'm going to ask us to actually then look at these and answer them. Okay, so that is 70, that's 50, that's x, that's 83, that's 80, 67, 43, and x, right? Yeah, so I'm going to give you a few minutes to do these. Okay, so the moment you guys are done, I'd love not that guy to lead us in answering these questions. So let me know when you're done, not that guy, so that you can lead us.
I'm done, sir.
You done? Okay, let's go. Lead us. Lead us, our leader.
Okay, so number one, I wrote x plus 70 plus 50 equals to 180.
All right, awesome. What's the
But
reason?
my reason is angles on a straight line.
Sure, epic. Okay, so we are on like a sweet upward climb, and it seems like our journey is good so far.
Yes, sir.
Continue.
And then from then on, I said x plus 120 equals to 180. From then on, I continue to say x equals to 180 minus 120. And then my final answer is x equals to 60 degrees.
Okay, and I think there's a deafening. Beautiful. Well done. Well done. So yes, that's how it is. All right. Okay, number two.
Number two, it's x equals to 83 degrees. And my reason is vertically opposite angles.
Okay, epic. X is equal to 83 degrees. Your reason is vertically opposite angles. Nice.
Then number three is the same thing, but x equals to 80 degrees.
All right. Hang on there. You said x is equal to 80 degrees.
Yes.
Right? And then you said your reason is?
Vertically opposite angles.
All right. Hang on there. Let's hang on there. Let's look at the diagram one more time. Okay. I'm sure you can see what you see about the diagram, right?
Yes.
How many angles do you see in the diagram?
I see 3 angles and angle x.
And angle x, right?
Yes.
So surely you know there's a relationship that exists for all 4 of those angles. For instance, not that guy. Do you see the angle 67?
Yes, sir.
Do you see 43?
Yes, sir.
Would you say those are vertically opposite angles?
They are opposite, but they are vertically opposite angles, but they are not equal.
They are not equal.
Yes.
So remember, the thing about vertically opposite angles is that they are actually equal. But in this case, these 2 angles, 67 and 43, are not equal. So we cannot then refer to them as vertically opposite angles. Yeah, right? So in the same language, your AD and your X are not referred to as vertically opposite angles. So the thing is that when we talk about vertically opposite angles, it must be that you see A, look at A, you see A and AL. Do you see that? You see AL?
Yes, sir.
Those 2 lines are actually not straight, right? If you look at A,
Yes, sir.
look at O, and then look at L, the 2 lines are not straight, right? Then if you look at B, you look at O, you look at D, all right? So those two lines are actually not straight lines. They are not straight lines intersecting. If it was straight lines intersecting, then obviously the relationship that would have to exist between the angles would be vertically opposite. But in this case, it's not so. So we need to look at another relationship where these angles are concerned. All right.
Okay. Another relationship I see
Yes.
is angles on a straight line.
Hey,
Which
once
is
again, you are saying angles on a straight line. But do you see that B, look at BOD. BOD is not a straight line. Okay. Maybe it's not as explicit here. And maybe the thing is, even my drawings, they are not as explicit. So I'll take the blame. Let me just do this. Can you give me a second? Let me redraw these so that maybe it will make a bit more sense. I'm sorry. Maybe sometimes it's just my drawings, and I'm sorry about that. So I'll take full responsibility for that. I won't hold you to my errors. It's my errors. So let's fix the error so that there can be clarity with this. Let me just redraw these. Just give me a sec. I'm sorry about the delay there. I just want to do this quickly. So let me redraw this so that it makes a bit more sense. The way I was supposed to draw this was this, that. Okay. This, that. Then maybe it will make a bit more sense. And I'm really sorry if it was, it's my diagrammatic representation of the sketch, and I'm very sorry about that. Okay. So A, D, L, B. Okay. All right. So here's the diagram.
Oh, okay. Now I see.
All right. Yeah, I'm sorry about that. I think I may have just loosely drawn the diagram without really taking that into consideration. I'm very sorry about that. Maybe if you relook at the diagram now.
I see now.
Yeah.
Okay, now I see a revolution, to be honest.
Yay.
So when I say x plus 60, 67 plus 80 plus 43 equals to 360.
Okay. Is equal
Then
to...
Then the reason is angles of a revolution or angles of a rev.
Okay, very important. Remember, we want to subscribe to that acceptable reason. You can say angles in a rev. That would be fine. Or you could say, alternatively, angles around a point, a PT. Okay, because we want to align ourselves to this acceptable reason document that they've provided so that there's no questions asked from us. Let it be that the teachers don't know, but Tina, we know. You know what I mean?
Yes.
Yeah.
And then from then on, we're gonna see x plus 190 equals to 360.
So when you add everything, 67 plus 80 plus 43 is 190.
Yes. X plus 190 equals to 360.
Then
we transpose the 190 that side. So it's x equals to 360 minus 190.
Okay.
And which will give us 360 minus 190. 170. X equals to 170 degrees.
Thank you. 170 degrees. Spot on. Thank you so much. All right. So just the point I wanted to emphasize, and I'm sorry it was my fault, guys. When I've messed up, I will accept the mess up. It was from my side. The sketch was not, was not giving. Now, if you look at the sketch here, this line AOL is not a straight line. BOD as well. So Remember, the whole idea of vertically opposite angles has to do with two lines that are straight which intersect each other. Then yes, of course, this angle will be equal to that one, and that angle will be equal to that one. If the two lines are both straight and they intersect, you can say that. But for this one, BOD and AOL, okay, see, the minute one is not straight, then basically you can't say this angle and this angle are vertically opposite, or this angle and this angle is vertically opposite. Vertically opposite angles has to do with two straight lines that are intersecting, all right? Then you can say that relationship exists. So in this situation, we have to look at something else. Also, here's another thing. You can't say that this angle and this angles are angles on a straight line, because this line is basically at an angle. You see, it's not straight, you know. So you can't say x plus 43 degrees is equal to 180, for instance. All right, and you say angles on a straight line, because yes, the angles are next to each other, but are they on a straight line? No. So these are some of the things that we need to always pay attention to. Let's not take these things for granted. Otherwise, hey guys, we'll think that we are answering the right thing, and then Gandhi, we find Kori, the marks are going, and yeah, they are not coming to us. They are going somewhere else. All right. Okay, the last one, my dearest Lena.
So for the last one, I'm not sure about my answer because
No problem. Let's
I'm
work
not
on
sure
it.
the
No problem.
answers. But what I wrote is x plus 15 plus 37 equals to 90 degrees.
Yeah, you are right. X plus 15 plus 37 degrees is equal to 90. Now I'm interested in your reason.
I didn't write the reason. I don't know the reason.
All right. Can someone in either in the comment section or comment what is the reason, guys, that we use x plus 15 plus 37 degrees equal to 90? He's 100% spot on where that is concerned. What is the reason? Does anyone know? This was very famous, this reason, in grade 8 and 9. Right, Tasha. Tasha said it in the comment section.
Yes, I wrote the reason right.
You also wrote the reason. Yes. Comb angles. This says complementary. So these are complementary angles. Okay. In the document, I don't think it's provided comp angles, but I mean, yeah, we use that for short. The angles are complementary, meaning the angles add up to 90 degrees. So complementary angles, we can just say comp angles, complementary angles. Tasha said it's complementary angles because complementary angles, they actually add up to
90
90
or
degrees.
90.
Yeah. So now you can go ahead, you can finish.
So then when I say x plus 52 equals to 90.
Okay, very good.
And then when I transpose the 52 that side, so x equals to 90 minus 52.
Yes.
The final answer is 38 degrees.
38 degrees. Nice. Okay. That was not too shabby, was it?
Yes, sir.
Yeah. So you can see our game is coming on where these things are concerned. It's very nice. Okay. I'm gonna write some more, and then I'm going to leave you guys at 10 o'clock specifically, if that makes any sense. 10 o'clock, I'm leaving you. Okay, this time round, find the small letters giving reasons. Okay. So I want small letter A, small letter C, small letter B. Okay, this time round we have straight lines, unlike the other diagram. These lines are straight, okay? Okay, so in the same way I'm gonna just write down the questions, and I'm gonna allow you guys to work a little bit, and then I'll come back and we'll answer. Someone will lead us in answering. So let's find B, we want A, we want C. We have F, we have capital letter C, we have capital letter D. Where does the name complementary angles come from? Wow, maybe, I don't know actually where that name comes from. So there's two words here, supplementary. Supplementary means adding up to 180 degrees. So when you have a sum of angles that gives you 180, we call those angles supplementary. Complementary, all right, also when we have the addition of angles and it's equal to 90 degrees, then we say those angles are complementary. I'm guessing if you want to know the etymology of the word, where its origin, do a meta AI search. It should be interesting. Or you can do a Google search and just check it out. Maybe you can come back to me and comment in the comment section and let me know where the word comes from. Okay, but that's the meaning. So I only know the meaning. I don't know where it originates from. But now you're making me curious, Landiwe, so I'll definitely look it up. Or maybe you can look it up and let me know in the comment section. That would be nice. Okay, and this is the other diagram. ABC. We want A, B, and C. Small letter A, small letter B, small letter C. All right, so this is the other diagram. Okay, so these are the diagrams basically. This one, 2, 3, 4. We want A, B, C everywhere. All right. Okay, and basically what you guys are seeing is just basic problems. And why am I giving you these basic problems? Because I want you to become familiar with utilizing the reasons that we have spoken about, the acceptable reasons. So that's why I'm trying to get you guys to become a little bit more familiar with the utilization of those reasons. Right? Some of you may be like, but where are the complex problems? We want something more meaty. We'll get there. Don't worry, we'll get there. Where your brain will just do all sorts of things, we'll get there. But for now, let's start here at the basic part. When we've got the basics down, the complex problems also become easy actually. There's nothing much to it. You just need to see what you need to see. And then when you've seen it, you can do it, okay? Oh, Tasha was eating. Now, some of you still don't need to have breakfast, eh? Just forgive me there. I shared a screenshot. That's why kind of the page looks like the way it does. Just trying to also give myself a break from holding the phone. All right. I think I've given you guys enough sufficient time. I think. What do you guys think? Do you think it's enough time, or do you need more time?
So it's enough.
Okay. So with this one, you can see the first diagram there. We've got 72. We've got C. We've got A. We've got B. How do we do?
Okay, so the first one, we're gonna say B equals to 72 degrees. The then again, what's this? What's the thing?
Reason?
The explanation. The reason is vertical opposite angles.
Okay, we use that short form. Vert op angles equal. Very important. Vert op angles equal. Right? 100%.
Yes.
We update our diagram. We now have B, which is 72 degrees. Next.
Then the next one is say A plus 72 equals to 180 degrees. The
Okay.
reason is angles on a straight line.
100%.
And then we go on to say A equals to 180 minus 72. Then A equals to 108 degrees.
Okay, nice.
And then C equals to A. And A into the value of A is 108 degrees. Then my reason is opposite angles.
Aye, you've got it. You've got it. All of it. You chowed all of that one. All of it. That first problem, 100% done. 100% reasoning, 100% statements. Okay.
And then the smallest value is B.
Yeah, definitely. So if we go on to the next problem.
The next problem is the first one. A equals to 45 degrees. The reason is vertical opposite angles.
Okay, very true. A is equal to 45 degrees, vertically opposite angles.
Then C equals to 45 degrees, which is corresponding angles.
Nice. Corresponding angles. And what do we make sure we don't forget when we write our reason for corresponding angles? There's something we need to make sure we don't forget.
AB is parallel to CD.
Nice.
And then we have we have C plus B equals to 180. And the value of C is 45 degrees. So it's 45 degrees plus B equals to 180.
Nice.
From then on, we transpose the 45 that side. So it's B equals to 180 minus 45. Then the answer is B equals to 135 degrees.
Aye, power to you, power to that. Okay, and obviously someone else may have probably taken a different road to the answers, but as long as our statement and our reason is 100% correct, we are good to go. Yes, let's move on, young man. You are doing very well.
Then number 7, we're gonna see C equals to 137 degrees. The reason is vertically opposite angles.
Yes.
Then A equals to 137 degrees. The reason is corresponding angles are equal.
Corresponding angles. Remember, corresponding angles, and then we need to state the lines that are parallel. Remember, here we have to always write corresponding. So corresp angles, and then we state the lines are parallel. We don't say corresponding angles equal. We say corresponding angles, and then we state the lines that are parallel.
Okay.
Yeah. So we need to be very, very careful when we write the reason here. Okay.
Then the next one is B equals to C, and the value of C is 137 degrees. Then the reason is, with the reason, angles that is parallel to C.
Sorry, you said B. Sorry, can you repeat that again?
Angle B is equal to angle C, and the value of angle C is 137 degrees. Then my reason is corresponding angles.
Okay.
Then AB is parallel to CD.
Okay, nice. 100%. That's fine. Right. Then, as we conclude, the very last one.
And then the very last one, B is equal to 112 degrees. My reason is alternating angles. And then AB is parallel to CD.
Nice.
Then A plus 112 is equal to 180. My reason is co-interior angles. So A is equal to 180 minus 112. Then the final answer is A is equal to 68 degrees.
Okay, nice. Just repeat that again. Just this one that you are doing. You said
A plus 112 is equal to 180.
Okay.
Then my reason is co-interior angles.
Oh, nice.
Then A is equal to 180 minus 112. Then my A is equal to 68 degrees.
Okay, when you wrote your reason, did you say co-interior angles?
Yes.
And then did you state the lines that are parallel?
Yes, I did.
Oh, okay. That's very important, right? Okay.
Yes, sir.
Okay.
And then we have the last one. C is equal to A. And the value of A is 68 degrees. And my reason is vertically opposite angles.
Buddy. Aye.
And the value of a B, what is it?
112.
Okay. How did you find it?
It's alternating with 112.
Okay. Thank you.
Aye. Mfanaka. I think that's what they say that side. Mfanaka. Aye. Like it's giving geometry is very weak, you know?
Sir,
Yes.
most these questions are basic questions for grade 8 and 9s.
Yes.
On the grade 10.
No. There are no grade 10. This is basic grade 8 and 9. Very important. Okay. Because remember, what did I say to you? I said to you, I'm trying to establish this thing of you guys using the correct reason and making sure that you know how to identify the angle. Remember, the basics of grade 8 and 9 are fundamental to the geometry as you go up. If these are not basic, I'm telling you, you know, can I tell you something? I'm teaching grade 12s at school. And I can tell you now that in the geometry that they do in grade 12, you will be shocked at how many grade 12 they do not remember or do not utilize these basics because they've forgotten. And as a result, many of them, they can't do the geometry properly in grade 12 because of missing out on the basic fundamentals. So what I'm doing with you here, I know some of you are like, hey, but sir, can we just get to the grade 10? The grade 10 is simple when the 8 and the 9 is basic to you. If this one is fine, you're gonna see what I mean, like when we move on to those complex problems. But for now, guys, I'm not gonna lie to you. Me, I want to iron out this thing until I am content that you guys are fine. Then we'll move on, and you'll see then, well, I suka, there's nothing to anything in the syllabus, even in grade 10. So I don't know. I know that maybe some of you might be getting impatient. That's fine. But me, I want to iron out the basics, and when those basics are fine, then we can move nicely nice along to the next and the next and the next. So I'm going to leave you with some work, because now I have to leave the live. You know, but I want to leave you with a lot of work. I'm going to leave you with this page of work. So maybe some of you will be like, hey, this guy, but yeah, so I'm gonna do that. Let me just leave you with this, and then yeah, we'll call it a night and it's day. So here, this one is solve or find x giving reason. Oh, that was a big yawning. I'm sure you took everything, Lerad.
So your phone is blurry.
I know. I don't know why. It's doing funny things. I think it's tired. It's like my phone is yawning. Okay, let me just see if I can't fix this quickly. Give me a sec. Alright, there we have it. Okay, just needed some fine tuning there. Sorry about the blurriness there. 1, 2. Yeah, please guys, maybe just screenshot so that we don't keep each other for too long. X plus 10 degrees, we have A, we have O, we have B, we have D, we have C. 70 degrees, we have X plus 30. We have 4.
Yeah, I go. And my baby is tired. Sidinjana.
Okay, so these ones you need to find A, B, C, D, and E giving reasons for number 8 and 9. Ten, 11, 12, 13, 14, 15.
Yeah, so can you screenshot?
Yeah, like I said, you can.
Like, I want the top one from there.
All right, I'll go back to it. Just give me a sec. I just want to write the last one, the 15th problem. Kuru, you can see we mean business here.
So when we're done, we're going to send it into your inbox.
Please do.
Okay.
So that way I can check and know, and then yeah, I'll take it from there. Hey, you wanted to screenshot the top.
Starting from number 1.
Take it from number 1, no problem. There it is. Find x giving reasons. P, Q, M, R, x and 2x, the box, which I'm sure you should know what it means.
Then can you go down from
2,
number
P, Q,
4?
R, S and T. Okay, let me just get the comment. Okay, let me look at the comment sections back on. Not yet.
Then 6 and 7. Eight and 9.
Okay, let me just, for a moment, for maybe others that are also trying to maybe they're just a bit slower than you. Just a sec. So that's 4, 5, 6, 7. I'm gonna go back to 1, 2, 3 for those that may have missed it. So that's 4, 5, 6, 7. That's 1, 2, and 3. Okay. Then let's move on to the next one. Sorry, 1, 2, 3. For those that did not get 1, 2, 3. 1, 2, 3. There it is. Right, then 8, 9, 10. 8, 9, 10. Want A, B, C, D, E, giving reasons for 8, 9, All right. And then we Cooper this x, we Cooper that x, we Cooper this a and b. Right, there's a box here, there's a 30, there's a 18 with the number 12 there. We want x obviously here. That's 14, that's 15. With 10, 11, and 12 also visible.
Yeah. I mean, I'm done.
Oh, that is so funny, Mina. I'm done. Sorry, I forgot this angle here. There's supposed to be 45 degrees here. So there's supposed to be a 45 here. We just recheck the diagrams again. So that's 100%. That's CDABA. 40, yeah, that's fine. That's fine. That's okay. That's okay. That's okay. Yeah, everything else is fine. Yeah, everything else is hundreds. 100, 100, 100, 100. Yeah. Okay. Gerardo, thank you. Yeah, enjoy the rest of your day. Check you out on the flip side again.
Thank you, Saya. And we should do more topics on the grade 10s, Saya.
Do what?
Do more topics for term 2.
Do more topics for term 2.
Yes.
What other topics are there for term 2?
Let me check then. Okay.
I know the other topics. I just want to see if you know.
Analytical. So analyze geometry something there and functions. Yeah.
Analytical geometry and functions. Okay.
Because my teacher, when she's teaching, she's like starting slow. Then when it's time for the exam and she's starting fast, jiggy, and you are failing.
Jiggy.
Like from term 1, I failed to trigonometry because of her.
What a strong way to say it. Okay, but nonetheless, we'll do the others. One at a time though. You see, so we'll do the others. All right. Well, guys, thank you so much again. It was good. I think it was real. I'll see you again when I see you, whenever that is. I don't know at the moment, so don't ask me. I have no idea. Okay. Cheers, Lerato. Can someone add me to the grade 10 group? Yes, I think ask someone there will add you.
It's mommy.
I told you, mom is not here. Yes. Just send me, not that guy, send me your just in the inbox. Send me a message and I'll send you the link. Okay. Last I checked, the TikTok didn't want links to be sent, but yeah. Mabuto, you're welcome. You're welcome. Just send me, message on TikTok. We'll sort it out. Guys, let me love and leave you. Thank you so much. Have a good one. It was real.